One thing that inversion or the inverse operations allow me to do is to get richer comparisons between values. We've looked at comparison before where I can check, for example, if 2 is greater than 5 or if 2 is less than 5. And so from this one, I'm going to get a false or a 0, and this one is going to give me true or 1. But this is just, a Boolean, 0 or 1, not very interesting. So the inverse operations will allow me to extract a value between two values and have a more interesting relationship between them. So for example, I have here the vector OA and the vector OB. And so I want to find the relative position of B if I would start from A. So there's several ways to word this. So I can word it like, what do I need to add to A so that it becomes B? Or, in a way, how does B look like from the context or the perspective of A? And so to solve this, there's this sort of general formula where I combine the value that I want to put in a new context with the context inverted. Or in this case, since I want to know what B looks like from the context of A, I'm going to combine B with A inverted. And that's going to depend on the operation. So this can be in abstract, this can be applied translation to a scale, to a matrix operation. But so let's look into here in translation. So if I want to solve this, I'm going to combine B with the additive invert of A. So this simplified will be B minus A. And this actually defines the position delta, this vector that goes from A to B. So the vector AB is solved by doing B minus A. And so this is where this can be a little bit counterintuitive because B minus A defines AB. Bit strange. Now, in a way, what I'm doing here is, since we always dealing with position vectors, I can't define a vector that starts at another position other than 0. So what I'm actually doing is I'm taking the initial position to the head position so that I can have the vector go like this. So if I solve this using these values, I'm going to get 5 minus 2, that is equal to 3. So this will give me a position vector that goes from 0 to 3. Now, if I want to draw this in context to make it easier, I can say that, for example, what I'm doing is I'm changing the reference unit vector so that instead of having its tail point at 0, it has the tail point at 2. And so now I can say that 2 becomes 0. And if I check the position of A, I see that it becomes 3, just like I found in here. Now I can go the other way around. And let's say that I don't want AB, I actually want BA. So let me just delete this here and delete the arrow and put it something like this. I want a vector, the position delta, that goes from 5 to 2. So I want the vector BA. And so what I want to do is to put A in the context of B. And so A plus minus B, the context is inverted. And so the simplified is A minus B, which is 2 minus 5, which is minus 3. So this is like I'm putting the reference unit vector here. And so this becomes 0, since if you remember, the identity of translation is 0. And so if I check the position of A now, I get minus 3. And these are the additive inverse of each other, or the opposite. So basically they have the same length, but they have the opposite sign. And so I know that if I have a position delta that goes from one to the other, I can go the other way around by just flipping the sign. And so this is called here, this I'm drawing here in context, is called position delta. And so delta means difference. And so it's a difference in position. It's a position that is relative not to 0, but to something else. This is what we get, for example, if I come here to modeler, and you'll notice that I have this cube, and here it's set at base. But if I put it on morph, you see that these top positions, they move away. Now, what's actually stored in a relative morph is not what we see in the viewport. What's actually stored is the difference between the base positions and the end positions. And so actually if we would look at the morph as it is, we would see something like this. So these are the relative positions from the base mesh to the morph, the base mesh plus the morph. And so this is what we actually store with morphs. And if you think about it, a position delta is a very, let's say, cost-effective way to store a series of transformations. So let's say that I have position A and I do a lot of things to it. I rotate it, I move it, I scale it, I do everything to that position. And let's say that it ends up in here. So I have here A prime. Now, the cheapest way for me to store all these transformations, instead of keeping the values, is to just do a position delta that goes from my initial position to my end position. So this way I know that if I'm given a base position, I have this delta and I can go to the transform position quite easily. So in a way, this position delta is summing up all the changes that the other transformations have done to my initial position. And that's quite nice. And so this is something that when we are here in Modeler and we change a mesh inside of a morph, that's basically what we're doing. We can rotate, we can move, we can scale the positions in here, that what it's stored, it's just the difference between the base positions and the positions that we see in the viewport after we changed it in the morph. Now we can also do this for not just for translation, but also for scaling. So instead of a position delta, we're going to get a scaling factor. And so a scaling factor is done in the same fashion as the position delta. In a way, I can word it in two different ways. I can say I'm putting B in the scaling context of A, or that I want to know by which factor I want to scale A so that it becomes B. So using this one in here, I can say that I combine B with A inverted. And so in this case, it's the multiplicative inversion instead of the additive inversion. And so with this simplified, I get B divided by A to 5 divided by 2. And so I get 2.5. And so this allows me to know that, let's say, instead of now changing the reference unit vector position, instead of moving it, I'm going to scale it from 0 to 1 to 0 to 2. And so my identity of scaling, it's usually 1. But now, since I changed this little reference unit vector, what I'm going to get is that the base is going to be at this position. And so 2 becomes, in a way, it becomes 1. And so then I can check, basically then what I'm going to get is that 5 becomes 2.5. So I can go the other way around. And so basically I can put this little reference unit vector instead of going from 0 to 2 to 0 to 5. And so B will become the identity 1 and A will become, let's do this. I'm going to put A in the context of B. And so I'm going to do 2 times 1/5. Or 2 divided by 5, or 0.4. So now A becomes 0.4. And if you'll notice, these two are also the inverse of each other. So in this case, they were the additive inverse. In this case, they are the multiplicative inverse, or reciprocal. Meaning, if I do, let's say, 1 over 2.5, I'm going to get 0.4. So if I have the relationship between one or the other, I can go the inverse way around by just inverting the value. All right, so let's look at an example of this in Lightwave. These sort of relationships that we can extract between two values, well, sometimes they are not used later on the values themselves. Let's say that, for example, I have A and I have B. And so I have let's say, a position delta between them. Let's say that I have here position C. I can apply in parallel this position delta between A and B to C. And so by doing that, by adding AB, doing C plus AB, I arrive to this position here. So I can apply the delta into other places. This basically, I'm extracting this relationship, and then I can apply that relationship to other contexts or to other values. So let's look at an example of that here in Lightwave. So instead of, in a way, it's not like I'm transforming the values, but I'm changing the number line. So let's do this one in here where I've put actually B in the context of A, where I put 5 in the context of 2. And so here I have 2 and I have 5. And if I just move this little reference unit vector from 0 to 2, you see that now 5 becomes 3. And if I move the reference unit vector to 5, 2 becomes -3. Now this is for translation. Let's check scaling. So I'm going to scale the vector. And so instead of having it with length 1, let's say that I have it with length 2. So now 5 becomes 2.5, as you can see here. And if I scale this to 5, Well, now 2 becomes 0, 1, 2, 3, 4 becomes 0.4, just like I found in here. So these are just quick examples of how you can change the context of values. Instead of having them relative to the usual identity values of 0 and 1, you can extract transformation values between values in the scene. And so this is a very basic and very common way of creating a relationship between two values. Now, since I looked into changing the context of a value, let's look into a routine that it's very common and it shows up everywhere, and it's called conjugation. So conjugation is basically, let's say that I have a piece of data and I have some values to apply on an operation to that data. But the operation and the data, the context of where the operation should be applied on, it does not match the context of my data. So I have to change the context of my data, then apply the operation. And then if I want to keep in the same context that I was before, I have to reinstate the context that I was before again. So it will look like this. Let's say I have my main operation. I'm going to call it O. And so before this operation, I'm going to change the context of it. And so I change the context, I do the operation, and then I want to put it back. And so to put it back, I do the inverse of this, which in this case is just like this. So let's say, for example, that I have these two values, let's say 0, 2, and 5 again. Let's say that I want to scale a position vector that goes from 0 to 2, and I want to scale it by 3 times. And so if I scale this by 3 times, I go from 2 to 6, let's say around here, because 2 times 3 equals 6. Now let's say that this scaling operation is having the 0 as the center. Let's say that I want to scale 2 with a different center. Let's say that I want to scale it having 5 as my center and not 0. So to do that, I have to put 2 in the context of 5, and then I have to scale it from that context. Then I probably want to bring it back to the initial context. So it will look something like this. I put 2 in the context of 5, so I get a position delta that goes from 5 to 2. Then I scale it by 3 times, so 1 time, 2 times, 3 times, and in this case this delta here will be a vector with position 3. So if this is the new 0, this will be -3. And so if I scale this by 3 times, I'm going to get -9. Now, let's say that I want to put this back into my main numbered line. And so to do that, I have to add 5 again. And so this is actually -4. So let me do the chain of that. I have let's say I'm going to delete this. And so I have my value, which is 2, that is going to be transformed. And so I have first the operation to change the context. So I subtract 5. Then I do the operation that I really want to do, that is to multiply by 3 or to scale by 3. And then I put it back where it was. So I add 5. And so this looks like 2 minus 5, it's equal to -3 times 3 equals to -9 plus 5 equals to -4. And so with this, you would expect, of course, 2 times 3 to be 6. But since I changed the center, I actually made this go into negative. So let's look at an example of that here in Lightwave. So I have this object here, A, and I'm going to use it to perform the scaling part. So I'm going to call an item info, and I'm going to put here A. And to do the movement, I'm going to call in here this object called reference. So instead of, this is going to serve as my center of scaling. And so if I put that in there and I put another item info here using reference, so now I can transform this value of 2. And so first what I'm going to do is I'm going to subtract the reference. So subtract, scalar subtract. Then I'm going to multiply to perform the scaling operation. And for that, I'm going to use A, the scale that I use in A. And then I'm going to put it back. So after my scaling is done, I can put it back into its initial context by using the same value that I used to subtract. So this is going to look like this. Let me put this in here. And so at the moment, my input is 2, and the result of this is also 2 because I haven't done anything. So let's say that I scale this object here by 3. So I'm going to put 3 in here. And so of course, 2 times 3, it goes to 6. But as I change the reference object, you can see that as I move the reference, the result of the scaling value changes. And so if I put this to 5, now the result will be -4. So what we're seeing here is basically how this input here called this input called center works. If I open up the compound, you can see that the first thing that is done to the value is to subtract the center Then I have the scaling operation and then the other operations. And in the end, I add back the center value. And so basically this is what the center value is used for, to subtract in the beginning and to add in the end. And so these operations sort of work like brackets around the main operation. We can see this in more complex sets of operations. Like for example, here, let's say I have this character and he's in front of a door that is closed. And so I see that I have this key in here and I want to get that key so I can open the door. Now, if I try to execute the grab action where my character is at the moment, I'm not going to get the key because I'm trying to do the grab action in the wrong context. I have to change the context of my character so that the grab action makes sense. And so in this case, I have to make my character go forward, then right, then down stairs. And then if I, in this context, if I use the grab command, now the character gets the key. So let's look into those steps. So I have operation A, operation B, and operation C. And so the first thing will be to have the character go forward, then right, and then downstairs. Then I grab the key, and now I have the key because I apply the command in the correct context. And then I need to come back, so I'm in front of the door so that I can open it. And so then I'm going to have the inverse operations in an inverse order. So it's going to look like this: inverted C, inverted B, inverted A. And so the character now, instead of going downstairs, goes upstairs, and then it goes left, and then it comes backwards. So inverse order and inverse operations. And so this is like all these operations are bracketing my main operation, which is just to grab the key. But by doing this, I get my character to actually get the key. Otherwise, he would just try to grab some air. He would get nothing. And so these things, in a way, sometimes it's like they're packing. It's like some things that you have to unpack, change what you want, and then pack them again, like a Matryoshka doll. So let's say that I want to flip the small doll upside down. But to do that, I can't just grab the whole doll, the biggest one, and just flip that, because then I would be flipping all the dolls, not just the small one. So what I have to do is I have to open the big one, then the next one, and then the next one, and the next one, and the next one, and the next one, until I get to the correct context in which I have just the little one. And so then I can flip it, put it back, and then I go the other way around. I start to close this one first, and then this one, and then this one, and then this one, and this one, until I get to where I started. So the last one I closed was also the first one I opened, just like I had in this sequence. The last operation that I've done is the inverse of the first operation that I've done. So this is a very common routine where we unpack things to have them in the correct context, and then we put them back, a bit like, some algorithms in Rubik's Cube. And so this is something very common, and so it's something to keep in mind, this term conjugation. And since I talked about applying the center, I talked about all the components of this compound, the scaling part, the translation, the reflection, and also the center now with conjugation. In the next section, the next video, I'm going to bring everything together and talk about the inverse transformation, basically the inverse sequence and the inverse operations of this transform 1D as I have in here. Cheers.